To protect the climate, we're changing in ways that might surprise you. We've turned to the most experienced fluid dynamics experts in the world to make airplanes more efficient. We're planning a heat pump the size of a soccer field to reduce our own emissions. Blazing a trail with recycling technology to breathe new life into old electric vehicle batteries. And to power our own factories. We're building an offshore wind farm, the biggest in the world. To protect the climate, we're changing, getting inspiration from all kinds of places and all kinds of people.
Hello, and welcome to our second event in the Sustainable by Design series. My name is Ben Glavatsky. I'm the Sustainable Business Strategy Manager at BASF, and I'm also the host for these events. So we had our morning session earlier today. We talked a little bit with our BASF Venture Capital Group. Now this afternoon, we have a session on resiliency through agriculture. Sustainable by Design is an event series that we are hosting for the next 2 weeks. So they're happening this week and next week. And we want sustainability to be on the forefront at the design phase of everything that we do. So we really want to design with the end in mind. So we have an exciting session planned for you today, live from North Carolina. I have just a few housekeeping items. So within the speaker console or within the presentation console, you will see speaker bios and some information on the right-hand side. And then there's also we have some additional resources. So anything that we have available, you'll see that there. We do have the opportunity to get questions. So if you have some questions that you'd like to post, please do so. Can't guarantee that we'll get to all of them during the webcast, but we'll do our best and then we'll respond to the others later on. Also very important, we do have a survey. That's a little bit harder to find. On the bottom, you'll see some boxes all the way across, some icons. The very last one is the survey, so we very much appreciate your feedback. So again, thank you for tuning in to this morning session. If you were there, thank you for tuning into this one, and I'd like to turn it over to North Carolina.
BASF Center for Sustainable Agriculture in Research Triangle Park in North Carolina. I'm the Sustainable Agriculture Advocacy Coordinator here, and if you're ever in the area, I welcome you to come visit us. So I would like to welcome you all today, both live audience and virtual, to BASF's Sustainable by Design event entitled Building Climate Resiliency Through Agriculture. Today, we will hear from 3 experts how different facets of agriculture are being used to build climate resiliency and answer questions along this topic. The United Nations predicts that by 2050, we will need to increase food production by 70% to feed the world, and nearly all new food production will have to come from existing agriculture land. I really like food, so this topic is important to me and my stomach. So first, we're going to hear from Dr. Mallory Shador, a soil microbiologist who will highlight the challenges and opportunities present within every gram of soil. Next, we will hear from Jonathan Vogel, who will give us an example of a plant variety specifically bred for surviving natural disasters. Finally, we will hear from Ray Daniels, an expert in engaging the value chain in sustainable farming practices. Each panelist will present on their topic of expertise for about 10 to 15 minutes, then we will shift into a panel discussion with time for audience Q&A. If you're joining us online, look for the Q&A box to submit your questions, and on site, we will answer questions here as well. We want to encourage an open and active dialogue, and we'll do our best to answer your questions in real time. And with that, Mallory, the floor is yours.
Great, thank you. I am an assistant professor and a soil microbiome extension specialist at North Carolina State University. And I'm so thrilled to be here to celebrate Earth Week and to talk about soil microbiomes and how soil microbiomes can contribute to sustainable agriculture. So before diving below ground into the soils, I want to take a moment to discuss microbiomes. We hear this word a lot, usually within the context of human health or food and nutrition. And that's because microbes are everywhere, right? And microbes are really the connections between our bodies and human health and also planetary health. So we define a microbiome as the entire collection of microbes, so the bacteria, fungi, viruses, the micro part. Also, importantly, where they live, right? Their habitat, so their home, how they make their living, so how they interact with each other, the biome part of the microbiome. So we have microbiomes. We have microbiomes in our guts. We have microbiomes on our skin. Animals have microbiomes. Plants have microbiomes in their leaves, in their roots. And the environment also has microbiomes. Microbiomes do not necessarily have to be associated with a host. So soils have microbiomes. The ocean has a microbiome. And each of these microbiomes is a unique system related to the microbes that are present, their abundances, the functions that they carry out, and also the broader biological processes that shape microbiomes. I don't often like to speak in absolutes, but soils are the most complex microbiome system on Earth in regards to biological complexity, right? So billions of cells in a small handful of soil. Chemical complexity, everything that decomposes in the soil is returned to the global nutrient cycle through microbes underground. And physical complexity. So this is a great illustration of how soils are this matrix comprised of living roots, dead roots, soil particles, and soil aggregates, right? All housing the many microbes living in the soil. So from the perspective of a microbe, there's a lot going on. And here are some colorized microscopic images showing you a small glimpse into what that soil habitat looks like from the perspective of a microbe. Okay, so backing way out again, these microbes are everywhere. They're in our agriculture soils. They're living in our crops. What are they doing? Well, they're doing a lot of very important things. Just as our microbes in us are responsible for our physical and mental well-being, microbes on crops are also responsible for crop health and I guess arguably maybe not emotional well-being of our crops. But so these microbes perform really important functions. And one of those is related to nutrient acquisition. So microbes provide crops with nutrients from the soil. This image is a field of soybean plants and legumes, so including soybeans and other crops like chickpea, peanuts, and clover, form important and close relationships with microbes living near their roots, in the soils around the roots called the rhizosphere. So these microbes, called rhizobia, establish in root systems in these nodules, which are shown in this image, and they fix nitrogen, so they are able to draw down nitrogen from the atmosphere and provide that to the plant in a way that is biologically available. So this is a really important relationship between microbes and our crops. In exchange, the crop provides the microbe with a pretty nice place to live and some carbon. So speaking of carbon, soils are also where large transformations of global carbon happens, right? So decomposing matter, microbes are responsible for the fate of that carbon. Does that carbon remain in the soil? Does it remain sequestered? Or is it decomposed and released back to the atmosphere as carbon dioxide? So really, microbes are controlling the fate of carbon between the biosphere and the atmosphere. And this story plays out differently across different systems, right? So this flow of carbon will depend on the soil, will depend on the geographic region, will depend on the environment, and will also depend on the active microbes in that particular space. So when we think of all of these beneficial functions in ag soils, most of these can somehow tie back to microbes and microbiomes. We talked about soil organic matter decomposition, that's microbes. Nutrient cycling, that's microbes. Microbes also enhance the uptake of water and nutrients to crops, so increasing water use efficiency. Ag microbes control the fate of greenhouse gas emissions in agricultural soils. They support collectively water retention and soil formation in soils. And they also have both direct and indirect actions to promote crop health. Direct actions, including growth promotions of excreting plant hormones that help plants grow, and also indirectly by suppressing pathogen and pest stress. So how do we optimize these beneficial functions in our ag soils? Well, we can do this through practices, sustainable ag practices that are designed to support and enhance soil health. So here are some principles of soil health outlined by the USDA, and all of these, again, tie back to microbes. So maximize biodiversity. Our above-ground diversity reflects below-ground biodiversity, right? So increasing diverse cropping systems. All of these other practices, anything that reduces the rate of soil erosion will have a beneficial outcome to our soil microbiomes. So minimizing the disturbance in our agriculture systems, maximizing the soil cover, having something on top of the surface of the soil, and then also maximizing the living roots within the soil. All of these practices, right, that are these cornerstones of sustainable agriculture are impacting our soil microbes. Right, however, climate change is here. It has been here. We're barreling towards future climate change scenarios, some with catastrophic consequences. So all of these environmental disturbances and stressors, increased saltwater intrusion, which is shown in this image, increased flooding, drought, increased temperature. All of these stresses that put additional burdens on our food systems are also threatening our soils, are threatening the biodiversity of our soils, and in threatening the biodiversity of our soils are also threatening to disrupt these beneficial functions that soil microbiomes carry out. But to sort of end on outlining opportunities, right? I'm a scientist, so that means I'm a problem solver, but it also means I'm a realist. And really, I think soil microbiomes have this great potential to influence how we build resilience into our agroecosystems. So we talked about these many beneficial functions that soil microbiomes provide. The challenge, though, is that there's high variation between soils, right? Between soil microbiomes, between soil microbiome functions. And what that means is there's not a single technology or a single solution that will address these challenges in every region and in every cropping system, right? But that's also an opportunity for innovation. The way that microbes and cropping systems will respond to environmental stress will again vary based on the stress and based on the environment and the geography. And this will certainly introduce cascading climate change impacts into our food systems and into our environments that we are not yet able to predict. However, again, though, this opportunity to center soil microbiomes and to translate microbiome science into sustainable agriculture is a really promising approach to build resiliency into our agroecosystems. Thank you.
Thank you, Mallory, for speaking with us about the importance of soil microbes. And next we'll hear from Jonathan about breeding climate-resilient crops.
All right, thank you. Good afternoon, everyone. My name is Jonathan Vogel. I'm a Discovery Breeding Manager here at BASF. And it's my pleasure today to talk to you about one of my favorite topics, which is crop productivity, in particular crop yield formation. So how do the crops that we grow, that we depend upon, how do they actually produce the yield that we want in the end? So today I'm going to talk a bit about corn, and I have a great example of a kind of visualizing this yield formation and how improving yield is sustainable for us and the environment. So this picture here comes from Bayer, and what you see here are different plots of corn plants that are all producing 10 bushels of corn. So on the far right of your slide you're looking at here, corn grown in the 1940s. You can see how much land was required to produce 10 bushels. Jump forward to the 1980s, you can see a dramatic decrease in the amount of land required to produce that same 10 bushels. And then as you kind of move forward in time, the land also decreases in over time. So what you're seeing is pushing yields higher, and we're really kind of reducing the amount of resources, in this case land, that's required to grow our crops. So I think this is a really nice example, kind of a visual one of how this works. And what I want to talk today a bit about is the future. And so on that future plot on the picture behind me, what we have here are, how do we get to that? How do we push yields higher with our crops? And so today I'm going to talk specifically about some traits that we can change in a crop. And a trait is simply a characteristic of a crop plant that we can change to improve its performance for something we want, which is in this case yield. So BASF and Bayer have been co-funding a biotechnology collaboration on yield and stress related traits. And those traits are aimed at pushing yield forward. And I think one example you can look at from the past of where this has happened is the Green Revolution. In the Green Revolution, this was where shorter statured wheat and rice varieties led to improvements in agronomic uptake of fertilizers. A decrease in height led to reduced lodging, and lodging simply when a crop plant falls over due to adverse environmental impacts like weather, wind, rain. So those improvements in wheat and rice led up to a 30% increase in yield in wheat, for example. So this is a big change. And so can we do something similar in other crops like corn? You can look at stature in corn, and corn's a very tall plant. Can you decrease the stature of a corn plant and get some of these other benefits you see, like reduced lodging? Now, breeders have been trying to do that for the last 50 years or so or more, and it's been very, very challenging. So typically you'll end up with a dwarf plant that's very much not a crop plant you want to put out in the field. It's not producing much yield. Or you can have something a bit taller, and it's actually producing an ear that has a lot of defects, and so it's not producing the grain that we need. So it's been very challenging to get that short stature corn. However, now I'm going to talk to you today about innovation coming from Bayer and BASF in this biotech collaboration, where we've developed a trait to confer a short stature onto corn without any of these negative impacts we've seen historically. And this work I'm talking about today was published in 2 different publications last year. I have a picture of this on the next slide, where you can see the corn plant. We have roughly a 1/3 total reduction in plant height. And so you can have the corn plant looks pretty much the same otherwise, except this reduced stature. And as I said previously, we've had issues with yield being limited or reduced in traditionally bred crops of corn. However, with this particular trait, that's not the case. So if we can have a picture here of some ears of corn that came from the tall corn plants, and then some short corn plants from the same background, and you can see that the ear sizes are equivalent. So there's no decrease in ear size. So what this equates to is an equivalency in yield, and so you're not having that impact of those negative changes I mentioned in the past. Now, we have this reduced plant height, you have a yield that appears to be the same. How does this perform in the field, and how does it hold up, as I said, with lodging? And I think I'm going to talk a little bit about that in the next couple slides. Because with climate change and seeing a warming environment, we're seeing more storms. And an example of this was in 2020 when this derecho windstorm went through the Midwest. It started up kind of in the corner of Nebraska and Iowa, came through Iowa, through Illinois and Indiana. And these were high velocity straight line winds. And so these storms were quite devastating. The estimates are around $11 billion to crops and to infrastructure from these storms. And to kind of take this weather radar picture, put it to something you might see, or someone who's not familiar with crops, what would it look like if you had high winds damage in a crop field? Here are some examples of lodging damage from these high winds. So these are photos taken by a colleague, Seth Baines, near his home in Iowa on his way to work. And you can see some fields where the crop plants, the corn, was blown totally over. So These storms could knock fields flat. They could cause damage sporadically throughout growers' fields. And we had a large impact on yields that year and the values that growers saw at the end of the season because of all this storm damage. Now, for better or for worse, we had a number of trial locations where we were testing this new trait in corn out in the field that year. And so this offered, challenges. Obviously, if you're trying to grow your crop and get some measurements out, if you have it knocked down, it's not such a great thing. However, in this case, we can also look at it and see how the plants performed in the face of this windstorm. So on the next slide, I've got a picture of that. And on the left side, we've got a representative lodging damage. On the left side is the short corn, and you can look at it, you can kind of make out the rows between the corn plants. So showing that there was very little lodging damage. But on the right side, you have some of the tall corn plants, and that becomes a little fuzzier and harder to make out distinctly those rows. This is because plants are lodged over and pushed down by the windstorm. So this is kind of a visual from above. If you go into the fields and take some measurements, we were noticing 50% damage in these tall plots, and only about 25% in the short-statured corn. So a big difference right there in just kind of the damage taking those measurements. And then if you wait to the end of the season about what we care about most, which is yield and how much grain we get out, I've circled the box in blue there on the left side of those bar graphs, where the black bar represents the yield that we got from the short-stature corn, and the white bar is the tall corn, and you can see there's a pretty significant difference. This was a 12% yield difference between the two across these locations that were damaged by this storm. So what we're seeing here is this trait really does allow the plant to withstand lodging stress, and it doesn't lodge as readily as the tall corn. So we're seeing that in the end then, and what we need is in yield. So this kind of information allows us to kind of run a thought experiment, and some modeling was done to kind of see, well, what would have happened if instead of having tall corn planted in an area that was impacted by the storm, what if that had been short stature corn? So we can run that thought experiment based on the yield differences we're seeing here. And the area that was impacted by this storm was about 4 million hectares, which is about 15,000 square miles, or the size of the state of Maryland. If all of that area had been planted with the short stature corn, and you had that yield bump and less damage, what would have happened then to the economic loss that the growers would have had seen with the storm? What would they have gotten with the short stature corn? Well, they would have had an increased yield, and they would have saved roughly $1 billion in economic value. So that loss that happened would have been avoided with the short stature corn. Additionally, in agriculture, you don't get anything for free. There's a lot of effort that goes into agriculture. Going out, planting the crop takes fuel, it takes resources, it takes agricultural inputs. That means carbon spent. Any carbon we spend on agriculture, we want to get something back from that. We want to get that yield. We want to get that grain or fruit or whatever we're growing. If a storm blows that over and you can't harvest it, that's loss, and that's lost carbon as well. So you can model that as well, and you can see how much input you put into your field, how much you saved in yield, and how much then carbon you now have saved. In this particular example, you would have saved 1.48 teragrams of carbon or carbon dioxide equivalents. That's kind of an abstract number, at least to me. But if you look at that and look in terms of something you and I are used to, which is driving around, that's actually equivalent to about 3.7 billion fewer miles driven by automobiles in the US in a year. So 3.7 billion fewer miles driven is a pretty big carbon impact. So that's really nice to see. So that's yield and grain we got back and spent carbon for, and now we're getting in that case. So I see there's potentially some really big values for society and for growers into having this trait out in their hands and in the marketplace. So with that, I just want to kind of summarize and just say again, BASF and Bayer are co-developing this biotechnology trait for growers. Expect to see it with growers in the second half or the later half of this decade. I talked a bit about the benefits today, which include the reduced crop loss. I didn't get to it, but there's also an impact from this reduced height of access to growers for their fields. And if they can go into the field and do more targeted applications, that can have some sustainability benefits as well. And finally, these two things together, this reduced crop loss, saving carbon, saving yield, leads to increased environmental sustainability. So this is going to be, I think, a great win for agriculture to have this increased sustainability from reduced crop loss, especially with warming climates and knowing that these storms are potentially going to be more prevalent in the future. And just as of right now, growers do experience lodging every year. And so we're going to see savings, I think, for growers every year just from the normal weather events that everyone is seeing. So with that, I want to thank you and hopefully you have a good message for why crop yield improvement is sustainable.
Thank you, Jonathan. And now we'll hear from Ray, who's going to talk about delivering value and sustainability.
Well, thank you so much. I got to tell you, I was a bit nervous listening to these two there. You can tell we've got some of the leading minds and intelligent people in agriculture and in sustainability. So it's honestly a pleasure and an honor to be up here with them today. So I'm going to talk about a couple things and how we think about value and sustainability in agriculture. And I'm going to talk about three things that are important. One is the farmer's perspective. When we talk about agriculture and we talk about sustainability, we mentioned carbon, soil health. But what does that mean for a farmer? And I'm going to share some statistics around that. Secondly, I want to also we talked about sustainable ag practices. And for those of you in the room or online that are not familiar, like some of us are every day with these practices, what do these look like and how do they contribute to improved soil health? So I'll talk a little bit through that. And then finally, importantly, how do we at BASF engage the value chain and in what ways can we help bring some of these results to life? And then what are some things that we are doing today and potentially in the future that will help further this? So I'll share that as well. But before I get started, I wanted to ask one question, which I get asked often is, so why BASF? Why are you involved in this? And really, I like to answer that because I think sustainability is really key and core to who we are. We've got colleagues across the US and Canada and around the world, very brilliant colleagues who are doing some incredible work in trait technology, but also in how we approach the market. And then from a commercial perspective, we're finding ways each day to help reduce our environmental impact and make it a more viable outcome for the farmer. So for us, sustainability in agriculture is really, it's the future, and it is really important to how we see ourselves in that future long term. But first off, let me start by saying that's how we see sustainability. But first off, let me talk about how farmers see sustainability. And I'm going to pull out some notes here because I've got some quotes on this. But so before you can really provide any value to somebody, right, you kind of need to know what do they value and how is that important. So going about this, we asked farmers via some research we did last year questions around when it comes to sustainability, what does that really mean to you? And I'm just going to share some quotes with you that I pulled out of this research that we asked of farmers across a variety of crops across the United States and into Canada. What do they think about sustainability? So I'll give you a couple quotes. One is sustainability is being good stewards of the land so that future generations can use that land. So it's not just about yield and what we're getting today, it's about the future. Sustainability involves making decisions that have little or no negative effect on the environment. I love this one. Being able to stay in business today, the next month, the next year, and for the next generation. So the economic leg of this three-legged stool is critical. And then finally, taking care of the land and environment, planting the best seed, responsibly using chemistry, and incorporating natural practices to reduce artificial inputs and improve overall soil health. This is what, when we talk to our farmers, this is what they think of when it comes to sustainability. This is what is of top of mind for them. And for us, as we think about our innovations and as we think about the improvements we can make and ways we can help farmers improve on their operation, we have to think ultimately about those elements. And a lot of that boils down primarily to soil health, as Mallory mentioned earlier, and then where those innovations fit in. We talk about sustainable ag practices. These are things that farmers today are doing and can do more of on their land to help improve the overall soil health. As we mentioned earlier, I can't reiterate the importance of soil and how important that is to the environment and to the farm, because without soil, we don't have yield, we don't have consistent yield, and ultimately we don't have, the land is really not productive. And so everything we do from a technology, but at a practice level, has to go back to building soil health. And some of the things that are important in soil health that matter are certain practices that go into farming. First off, there are three main practices I'd like to share. One is tillage. When it comes to disturbing land, reducing or eliminating tillage on agricultural land is critical. If you think about the Dust Bowl, or if you think about West Texas or anywhere where there's a major drought and you see dirt blowing around, every time that happens, those are nutrients and inputs that are taken out of that soil microbiome that are no longer available for plants to take up. So reducing tillage or eliminating tillage is really critical for farmers to help build back more soil organic carbon into that land and help improve yields long term. Another practice that was mentioned as well is what we call cover cropping, which is essentially planting plants in between crop rotations. Those can be things like clover, legumes, or pulses in Canada, chickpeas, lentils, and a variety of other things that we can plant in between crop cycles that help do two things. One, it helps against soil erosion, so it binds the soil. I mean, the more roots you have in the soil, right, it can't blow away. Secondly, it helps filter water and prevents nutrients from running off. A good example I can give you if you want to look it up is if you take water that's run off of two different fields after a rainstorm. Imagine one field covered in grass or clover or something that's green, and take another field that's completely brown and look at it, and it's completely dirt, and look at it after a rainstorm. The water you would pick up or you would collect from a field that is tilled and bare would be brown, right? It'd be full of silt and soil, right? The water you would collect off a field that's been cover cropped would be almost clear. And just the amount of soil and the filtration it has on that land has a huge impact at keeping the nutrients intact, but also keeping the soil intact. So cover cropping is another key area when our farmers think about practices, it's important. That's one. The third one of these, and there's multiple practices. The third major one is nutrient management and the judicious use of nitrogen. Right? We know that we can't achieve crop yields in plants without nitrogen. That's a natural part of how we raise plants. But what we can do is think about where we use nitrogen in a manner that gets the same yield without overuse. And today, we have come so far with precision agriculture and the ability to apply nitrogen at the right place, the right time, leveraging the right source, and at the right rate in such a way that we can achieve those yields by limiting and reducing the overall amount of nitrogen that we put down. And these practices, while they may not seem groundbreaking, they're part and parcel and core to a more sustainable farm operation and a more sustainable food supply in the future. So these are what our farmers are doing today to improve soil health, build back carbon, and ensure that they can continue producing at the rate they are in the future. So when it comes to BASF, what are we doing in this space? Like, we're not necessarily out there tilling the land, are we? But one of the things we look at 4 different categories of things we can do to help the value chain, help our stakeholders, and help our farmers to achieve more sustainable outcomes. The first is regenerative and climate smart agriculture, and I'm going to give some examples out of each one of these. The second is biodiversity. The third is stewardship, and the fourth is advocacy. So under regenerative and climate smart agriculture, we already get a great example of short stature corn as a way a technology and a product or a seed innovation can help create a more sustainable product. So we have products in that, but we can also incorporate programs. And I'm going to share an example that we have in our cotton business. Program is called the E3 Sustainable Cotton Program. And this is a program that helps farmers track and measure the environmental inputs and results of their cotton crop, and attach the data from that to the bale of cotton as it's produced and sent off down the line. And the importance of this is because we mentioned the profitability aspect earlier. By attaching environmental outcomes and the sustainability data to cotton, farmers can in turn get a better premium for their commodity. And of course, that cotton goes on to the manufacturers of your shirts or your towels or whatever else in the value chain, but that's a clear way we can help our farmers extract more value out of the chain based on the sustainable practices they are doing in that cotton program. Under biodiversity, we have multiple initiatives. We have several on site. If you're here in RTP, there's a beautiful pollinator and flower garden outside as a pollinator sanctuary. But we like to take some of these initiatives further out into the field where our customers are. So we're actually in partnership with a conservation group called Pheasants and Quail Forever, where we're working together along with several other industry associations to help farmers specifically in West Texas to identify land that they can convert into wildlife habitat. And you might say, well, that sounds counterintuitive. Why take agricultural land out of production and turn it into habitat? Well, some of these lands really aren't that productive to begin with. And it gives the farmer another income opportunity, but also an opportunity to build more biodiverse biome for that farm. And that is one organization that's helping us to work with farmers to identify land as well as identify programs that fit the needs of that operation. So biodiversity is key to us in helping our farmers incorporate it. Stewardship, I think it goes without saying that stewardship is really critical to if you're a seed or a chemistry organization, but also helping our farmers be better stewards of their land and communicate the value of what they're doing. I'll go back to the example of the E3 Sustainable Cotton Program. Via the work that we're doing, we're actually able to collect and help them collate the data from what they're doing to show the improved outcomes. And as a part of that, just giving you some data from what's from 2022, we had over 3,700 tons of carbon removed from the environment as a part of those practices I mentioned earlier, which is the equivalent of 724 cars, not quite the 3.1 billion you mentioned earlier, but 724 cars off the road for a year. That's a pretty good amount. Secondly, through the no-till and some of the cover cropping and some of these other practices, they tracked over 470,000 tons of soil that did not get lost to erosion, which equates to about 1,700 football or soccer fields worth of dirt. And that's a lot to keep in place. And finally, over 73% of those farmers that were involved in that program built back organic carbon into their environment, and hopefully which will translate to improved yields long term. So that's an example of how we can be better stewards and help our farmers steward what they're doing. Finally, I want to touch on advocacy. We're obviously involved in a lot of different organizations in helping farmers' voices be heard. But two things that we, from an advocacy standpoint, we do. First off, we have a team of policy experts in Washington, D.C. that are working with our trade associations to ensure, and policymakers to ensure that the farmers' voice is at the center of the conversation as it relates to legislation around sustainability, the upcoming Farm Bill, and other factors that impact their land. So we want to make sure the farmers are included in that conversation. They are the originals in conservation in so many ways, and they have many of the solutions that we need. Secondarily, this Center for Sustainable Agriculture here in our Research Triangle Park, this is one place where we are engaging the public, policymakers. We're leveraging it to help introduce school children as well as other members of the public into what agriculture is and sustainable agriculture. And this is a place, like Sam mentioned earlier, I encourage you to visit, because this is another way we can help advocate on behalf of our farmers for the work that they're doing by educating the others in the public. So those are some examples of what we're doing under kind of our key pillars of sustainability. And then finally, I'm going to close by saying, this is so what? I always guess. So where's the value? Right? Remember the old commercial from the 80s, like, where's the beef, right? Where's the value in this for the farmer, and where's the value for us? Well, let me state this. As I mentioned earlier, sustainability is core to who we are. It's the reason why we do a lot of the work we're doing and some of the innovations and the way we look at the future. But it's more than a product, it's more than a program, it's more than a gimmick or a press release. Sustainability is an expectation from our value chain stakeholders, everybody from the farmer to the consumer and every channel in between. And so as we think about sustainability, that is an expectation from our farmers and our stakeholders, is to help them achieve their sustainability outcomes, leveraging the technology and the advice and the products we have. So for us, a lot of it is really helping to deliver on help them deliver on their sustainability goals and be a trusted advisor in that process. So that's where BASF, the value for us and value for the supply chain and all those stakeholders comes to light. So again, I hope today you learned a little bit more about the work that we're doing. I hope that you understand now what farmers think when it comes to sustainability, have a better understanding of sustainable agricultural or regenerative agricultural practices, and walk out of here today knowing that we are doing things today that help drive that, but we're by no means done. There's many more things we have yet to do in the future, and we're continuing to grow and learn and add to this. So sustainability is really, again, core to who we are, and and I believe with the people we have and what we're doing, we're going to help farmers achieve some more sustainable outcomes long term. So, thank you very much.
All right, thank you, Ray, and thank you all speakers for sharing about your expertise. And now we're going to transition over to the discussion portion of our event. I encourage you, if you haven't already, to submit a question online, and we will also take questions from our local audience. But I am going to start off, since we are in the Center for Sustainable Agriculture. Really, for any of you, what does sustainable agriculture mean to you?
All right, I'll kick it off. So I think we've spoken sort of on the practice of sustainable ag and the idea of food systems that are resilient to match the nutritional needs of future generations. But I think what this means personally, more from a collective philosophy, is that we acknowledge that our agriculture and food systems are not only embedded within natural environments, but also embedded within society, right, and the socio-political systems, right, including systems of systematic and historical oppression and inequity. So in order to bring our food systems into the future under future climate change scenarios, that really means sustainable agriculture needs to center environmental health and also social equity and the well-being of human society.
I guess I'll add on to that with some of my thoughts on this. To me, sustainable agriculture means to do as much as you can, so to produce as much yield, and I'll stick to the yield theme, as possible with the least amount of resources as possible, and in such a way that it allows us to maintain that land for agricultural productivity far into the future. So I think we have we have to take care of the generations who exist today, the people on the planet now, and we know that that population is growing, and so we have to have responsibility for the generations to come as well. So we need to, I think, continue to keep our yields high. We need to maintain that land and do it in such a way we have the least amount of resources really going into agricultural productivity. It's a really big challenge too. I mean, human society, as we heard, Mallory said, really depends on agriculture. We're based on agriculture. So our society as we know it would not exist without agriculture. And so I think we have to really think about how do we maintain that going forward and how to do the most with the least resources.
Yeah, and just to bridge, I don't know if I could say do more with less the same way as well, because I totally agree. I think for me, it comes to a couple things. One is do no harm, which is a lesson I was always taught, do no harm. And we realize the need for food, right? We have got to eat, and we know this. But at the same time, we realize the importance of the environment and the world and our home planet that we live on, right? And we can't forsake one at the expense of the other. And so for me, sustainable agriculture is a way to help continue feeding a planet in a way that helps improve, not necessarily improve, but manages some of the changes that we're seeing from a climate perspective. And doing so in a way, again, does no harm and leaves this place better than we found it.
Excellent answers. It does look like we have some questions coming in online, so I invite Jessica Monserrati to read off a question or two.
We have quite a few. Sorry, I will adjust. This one is for Jonathan. Is the nutritional value of the short-statured corn the same when consumed from tall or conventional corn?
That's a good question. As it's a biotechnology trait, that's going to be determined in the regulatory studies. And I would say that any trait that ends up on the market has to be equivalent. And so in the end, I don't think you'll see it on the market if it's not equivalent. So I think that's the short answer to that. Yeah.
Another one? All right. This one is for Mallory. How far away are we from soil-free agriculture? Is this even a sustainable solution?
Well, I mean, at present, we have systems that are soil-free, right? I guess in a highly controlled system, you could essentially be microbe-free, right? Microbes provide all of these benefits, but if you were able to provide a plant with water and nutrients, essentially, you could also have a microbe-free agriculture system. So I think I think the technology is there, right? And also a world of artificial intelligence. We have the capability to move away from that. I don't think the infrastructure and sort of like the built systems required for that type of food system matches our technological ability. So I do not think that a soil-free ag system is the most sustainable and likely path forward.
Thank you. Ray, this one's for you. What are some examples of no-tillage practices? And a second part of that question is, how do they plant seeds without tilling?
Two good questions. So to give an example of no-tillage practices, if you're driving out in a rural area and you're looking across the field, right, it's easy to call it out, but if you're looking across the field and you see one that's freshly tilled, it's rather, not freshly tilled, you see a field that's in planting spring season and it's in clean rows, it's very nice dirt. That's an example of what tillage looks like, right? An example of no tillage might be you're driving by a field and it looks like someone mowed it over and just left it, the residue or the hay or the crop left behind. It might look a little messy, and maybe your lawn could look this way too. That's the difference between the two. The no-till field is going to have all that material that's left over, the crop residues from whatever was planted, gets converted back into nutrients and others that go back into the soil. A tilled field is going to have some of that removed and maybe incorporated back into the soil, but it's still, the soil is going to be there available for erosion and other things. So that's an example of the two of them. That's if you really want to look at it. It's bare ground versus ground that's covered by some other organic matter. And the second question is, you mentioned, is how do you seed in that case? Yes, there are different, in precision ag, we have different seeding technologies and implements. One of them is an air seeder, and they use these quite a lot in places like Alberta, Canada, where the soil is not that deep. So tillage is something that is actually frowned upon if you own the land because you don't have as much to go around, so you need to preserve it. So farmers there in the canola space actually inject the seed directly into the soil as they go along. And a third alternative could be strip tilling, where you're just tilling just a small portion of the field before you plant your seed, as opposed to tilling the entire acre of land. So that would be an example of both, and then how you would seed that.
They are coming in. So do you want to keep going? All right. So Jonathan, this one is for you. When one pushes yield, this is a three-part question. When one pushes yield, does it put additional stress to soil, water, et cetera? It would seem as though mass produced is increasing per acre, the consumption would also go up. And so the third part of the question is, how can we be sure that we are balancing yield with impact?
I'm going to start with the last part of that question, because I think, how do you balance yield with impact? And I think it's a societal question, right? Because you're growing food for people. And so in the end, you're growing food for all types of activities that humans are doing. Either it's growing animals for food, eating the crop directly, et cetera. So I think the balance becomes a societal issue of how we do that as a whole society. In terms of, what was the first part of the question again? Sorry.
When you're pushing yield?
Oh, when you're pushing yield.
Yeah. Are you impacting resources?
When you're pushing yield, you are not necessarily impacting, let's say, resources in the terms of, the soil per se, but you have the inputs that go into that crop are higher. So, you need additional nitrogen, potentially nutrients, et cetera. So the style of agriculture we do depends upon, the inputs you put into it. However, if you don't have that yield improvement, suddenly you need to have a lot more land in production to produce the same amount. And so I think this is something that's, again, it's a societal question of how you balance, like, how much land do you put towards agriculture, or how much land do you put towards other uses for biodiversity or for places for people to live. So that's kind of, I think, the balancing act you have to do with any types of agriculture that we do.
Thank you. Mallory, I've heard that biodiversity below ground can serve as a proxy to above ground biodiversity. Do you care to comment on the validity of that statement?
Do I? No. But yeah, great observation. I think in general that is a valid statement. I think it's also safe to never speak in in absolutes, right? So soils are really complex systems. So sort of those feedback between above ground and below ground metrics of biodiversity are connected in ways that are often nuanced and cryptic. So, but I think it is a fine, solid statement to say that below ground biodiversity reflects above ground biodiversity and vice versa.
It's great to know. I'll kick it over to you so we can go through the next.
I had a really good question. Okay, so Mallory, what do you think agribusinesses such as BASF could be doing to further help our farmers, our growers, maintain soil diversity and health?
So I think that we're in this age of immense data opportunity, right? We're generating so much data through different measurements, through different technologies, again, through the integration of artificial intelligence. And I think there's a lot of opportunity to sort of digest this data and synthesize actions and decision making and extend that information in a way that is accessible to all growers. Not only accessible from a data perspective, but targeted at the individual goals and value systems of various cropping systems, of various geographic locations, of sort of local communities, right? So prioritizing and targeting these food system needs across different locations. I think there's a lot of not only opportunity, but I think there's an ethical responsibility for agribusiness to prioritize these questions.
I agree. Ray, do you have looked like you might have had a comment on that? What are your thoughts?
I think, yeah, mine's great. I think to bridge on that, I think one thing we can do a better job of, right, is finding ways to continue to equipping farmers with the information and the practices and the real data, the support. And we have the data, but what does that really mean? But what does that look like in literal translation on a farm? And also, like an example I gave earlier, how can we help translate that into something as meaningful for their operation, but also meaningful for society too? So being able to explain the carbon impact of what you're doing, and for people who are, who want to know that, I think that is a way we can, as agribusinesses, we can go a bit further than just the technology and help translate and tell the story behind what that technology and those outcomes are doing.
Excellent.
For you, Ray, can you grow cover crops with your cash crop at the same time?
That's a good question. In some cases, yes, you can. There are people who are rotating between the two. I think it's a question of the area you're in and whether that's going to make sense for your operation from an agronomic perspective. Also, intensity of the soil, right? And so, can you do it? Yeah, but should you in certain cases? No. Some farmers choose not to do that at all and just leave it fallow. So I think it all goes into, it depends on the area in which you're working, in the area in which you're farming.
Okay. Yeah. Jonathan, I have one for you. The storm that you described seemed to have had a very dramatic effect. Could you comment on the monetary loss a typical grower in the Midwest would experience with a similar size storm today?
On a similar, I think for a similar size storm, you were probably going to see a similar size impact, but crop prices have gone up since that time, so the economic loss, I think, would be higher as well. Mm-hmm. There's always the balance of how much crop is, how much is corn, soybean, and those kind of acreage, and what other crops are out there. So you're always going to have that into the model. But you can, for a storm of the same size, I would imagine it'd be even more of an economic loss going, for storms in the future. And growers are seeing losses every year from just, more local events that, don't get as much, let's say, media attention as that such a giant storm moving through. Yeah.
Great question for Mallory here. How can we improve the diversity of the soil microbiome in modern monocultural systems?
In monoculture systems. I think an opportunity, right, is to work with plant breeders to breed back in beneficial relationships with microbes, right? So there are opportunities within any system to recruit, stabilize, and maintain diverse soil microbiomes, right? So these systems vary across location. So there are certainly additional strategies, whether that means management strategies, inputs, or cropping varieties that are able to stabilize those existing microbes to form diverse and functioning communities. And I think importantly, there's an opportunity for managing ag systems that can conserve local biodiversity, right? So that's we can't always observe below ground biodiversity, but there's vast communities of ecological diversity. So our ability to conserve those sort of local patches of regional biodiversity is I think a great opportunity for managed agroecosystems, and I think that maybe monoculture systems aren't the best way to do that, but there are certainly strategies within any cropping system that we can optimize the local microbe habitat.
Very good. I have one for you, Jonathan. It is interesting. I actually had direct experience when our farm was rice field and wind was demolished the productivity. Is there any development for rice plants similar to corn?
Oh, so that's a good question. So rice, as I said earlier in the talk, the rice and wheat were some of the original Green Revolution plants. So the reduced height, you saw that in wheat, you saw it in rice, and that led to that increase in lodging resistance and ability to take up nutrients and use them more efficiently for yield production. So those crops have kind of gone through that already, kind of on a more global scale. And maybe the questions kind of think more towards kind of a local individual issues and like weather events, which can I think always be an impact. I think any solution we're talking about, be it the Green Revolution traits, this trait in corn, it's not 100% protection against something happening or something being 100% protected. So I think you're always going to have that risk of crop loss in anywhere, and it's just a matter of to what degree. I mean, there's a very big difference between a 90% crop loss and a 30% crop loss. So I think we're probably kind of in that range, I think, across society, thinking about like how do we minimize the losses and not have those really dramatic and horrible losses.
Understood. Yep. And I have a last one for Ray. Can you speak to your outreach advocacy strategy with existing farmers?
Outreach advocacy strategy with existing farmers, I guess I can speak to a couple examples of what we're doing to that. One is we are continuing to partner with organizations like CropLife US and Canada, working with the Canola Council of Canada, for example, to help give the right information and data points to support sustainable ag practices. One example that could be is to actually provide data points around nitrogen and usage on certain crops so that we can help make back up some of the decisions that those farmers are making and what those organizations are trying to encourage growers to do. So those are areas of that. Now, a final example is in cotton. We leverage our farmers that are enrolled in this E3 program as to help and promote their sustainable practices via podcast and other methods, communications channels, to help get the word out on the work that they're doing, whether it be and we use social media to that end as well to kind of highlight some of the great work that they're seeing on farm. And that's just, again, one of the words we're trying to amplify their voice.
We are about out of time for our virtual broadcast, but before we close up, I do want to ask all of you if there's one thing you would like for audience members to take away from this chat, what would that be? So Mallory, you want to go first?
I'll go first. First, thank you, audience, for all of those fantastic questions. It's exciting to be able to talk about how technologies can build out more resilient futures. So my takeaway point is that in order to address these grand challenges in food systems and food security in the face of climate change, it's critical to adopt climate optimism. And I believe that because microbes are the things that connect us to health, and in human health and environmental health, I think that microbiomes, and ag systems can be tools and solutions supporting climate optimism in building more resilient food systems.
Thanks for that. For me, I would say I think farming truly is one of the biggest jobs on Earth. And as I said earlier, human society really would not exist as we know it today without agriculture. And so I think continuing to push the genetic gain, so improving crops going forward is going to be very important. And I think there's a lot of challenges there in terms of the climate and having the crops deal with the changes we believe are coming. So I think we need to continue pushing that forward. And so we need to keep doing what we can to grow the most food with the least amount of resources on the least land available, to allow us to have land available for biodiversity, to have land available for humans' use, other than growing the food we need. And so I think we need responsible to ourselves to do that today, and also responsible for future generations to make sure that land is there for them as well.
I would say balance, and to think that as we go forward with, farmers and agriculture is central to this conversation around sustainability and climate. I am very I'm an optimist as well, but I think it's about balance, and the decisions have to be made on the environmental, social, and the economic aspect. If we have to make smarter decisions and smarter practices environmentally, and I hope we shared some of that today. There is a social component of this that's very much relevant to communities and inclusion, as well as overall preservation of that land and its use by people, or granting access to others. So social has a huge piece of that, and then finally, it has to be economically viable. We can't ask farmers to continue doing more with less and expect to do the same year over year. If the economics don't pan out, it's really hard for farmers to stay in business and continue doing that. We know the number of acres that are being devoted to farmland is decreasing, but the number of people in the world is only going up. And so we have to find ways across all three of those balance from an environmental, social, and economic perspective to make this work for farmers. And again, hopefully today we shared some ways that we're doing that, and farmers are doing that now.
Well, I want to thank all of you for joining us today, both virtually and in person. And if you find yourself in the Raleigh or Durham area in North Carolina, I encourage you to come visit us at the BASF Center for Sustainable Agriculture. Let's thank our panelists for their time today. So thank you very much, and enjoy the rest of your day.